I love math, the way the path goes on the graph, how it functions. Cause great discussion in the math class.
Hey guys, Mr. Ng, your favorite math teacher here. Let's go over lesson 8.3, analyzing population data. Our learning target, we have these standards of mathematical practice, and you can just put in here an S. Whoa, don't want that one. S for statistics. I is the inference, and C is conclusion, and this is the standard. Use data from sample survey to estimate a population mean or proportion. Develop a margin of error through use of simulation models for random sampling. So we're going to talk about a population. How can you meet the standard? Well, I can use statistics and graphs to represent and compare data. We can also describe distributions by finding their mean and standard deviation. Alright, go ahead and try this warm-up over here, and then when you're finished, go ahead and press play, and then we'll go over that together. Joseph's diet for the first 6 days of this week consisted of these daily amounts of fat: 84 grams, 57, 65, 80, 76, and 50 grams. Find the mean, median, mode, and range of the data. So the first thing I'm going to do with this one is I'm going to put my data in order. So I have 50, 57, then notice I'm putting check marks to make sure I've already notice the data: 65, 76, 80, and 84. And let's just find the mean. So the mean is just taking the average. So if I add all these numbers up, 50 plus 57 plus 65 plus 76 plus 80 plus 84. And after today's lesson, you'll be able to figure this out in a different way. And there is 1, 2, 3, 4, 5, 6 numbers. So basically, this would give us um, 68.67, or 68 2/3 is your mean. Okay, the median refers to the middle. Middle. See if I can put that in there. Middle. That's what the median means. So you have 6 numbers. So if I put this orange dot there, you have 3 numbers to the left and 3 numbers to the right. So what you're going to have to do is find the average of those 2 numbers. That's what the median means, with an even set of numbers. Therefore, the median is equal to 65 plus 76, and you divide that by 2, you get 70.5 is your answer. And so we've done this one. Let's try the mode. The mode is what happens the most. What number appears the most? Is there any repeating numbers? There is none, so we would say no mode. Okay, and then the last one, we have the range. I guess that's the same as, I think, purple. Okay, so the range is the max minus the minimum. So the largest number, which is 84, and the minimum, which is 50. So that would be 84 minus 50, which give us a range of 34. Okay? Alright, which measure of central tendency best represents the data? Explain your reasoning. So this is actually going to be answered by today's lesson, but just to give you a graphical idea, you can make a dot plot. And if I have like the 50s, 55, 60, 65, 70, 75, 80, and 85. And so if I make a dot for each number, let's go from smallest to biggest. So I have one at 50, 57, 65, and then 80 and 84. You kind of draw your ghost or your more of the data is to the left. And one way you can look at that is your median and mean and median. So that would be the blue, this number, that's the mean, and the median. They're pretty much the same, 68 2/3 and 70.5. So the best measure of center, in this case, because it's symmetrical, which basically means it looks like a curve, a bell curve. I would probably use the. You can either use the mean or the median. But the big idea is that it's already symmetrical, and because it's symmetrical, you would probably want to use. It's close, but the mean's probably the first choice, and then median second. If this was non-symmetrical, use the median. Okay. All right. Let's change colors. Put a light red, pink. Suppose Joseph consumes 57 grams. So if I add this 57 grams here to my graph. Now my more of my data is to this side. Without calculating, how will the mean, median, and mode of his fat intake be affected? So that pink dot here, you'll notice that it's going to take those two white lines and pull it this direction. So mean and median would decrease. Mean and median would decrease. Okay, so let me try to explain that again. If you just on the 7th day you add 57, that pink dot here, it's more towards the left, so it's going to pull the mean and median, which are not really resistant, towards that 57. And then if you, well, that was my bad. The 57 should actually be right here. So then the mode would be 57 because you have two repeating numbers. Okay, so that's our warm-up. All right, let's take a look at our notes over here. And the measures of center and measures of spread or variation are often called something called descriptive statistics. To analyze data sets, we often look at their distribution. Another word for distribution is just the graph or the picture. So let me show you what that would look like. So this in our graph is this thing. Okay. All right, let's go into here. Let's go ahead and draw 3 graphs. All right. Let's go ahead and do a skewed right. So remember, like you're skiing, here is flat ground and here's your hill. And there you go. You're going skiing to the right. Right? And then let's just say you are symmetrical. Well, you can go any direction, right? And then a skewed left. Kind of looks like that. Remember, you're up here and you go this way. And all the data, there's nothing to the left there. So this one would be left skewed. Okay. We'll start with skewed right. Skewed to the right is also called positively skewed. Okay, here's the big idea. The mean and median are to the right of the mode. Alright, let me try to explain this. Okay, so here is the mode blue, and that's just telling us about repeated numbers. Doesn't really mean much, okay? And then the median, light blue, isn't really changed much either. But the one that was influenced the most was the mean. And this is how I'm going to try to describe it to you, okay? Let's talk about heights, okay? We take the average heights of our classroom. Most people are not that tall, but in comes Shaquille O'Neal, super tall person. This is Shaq, super big. And his average height is going to take the mean and pull it towards him. Because really what he is he's an outlier. He's like super tall. Okay? Alright, let's talk about the normal or symmetric. So they call this one zero skewness. So just big idea, it's normal. And this is what you need to know. The mean is equal to the median, so it's exactly the same, and it's also equal to the mode. All of those numbers are the same. So let's go back to our color coordination on the left side, okay? The mode, the median, and the mean are exactly the same. Okay, all right, let's try it over here now with left, okay? They would call this one negatively skewed. Sorry. Negatively skewed. All right, big idea for this one is, where is the mean and median? The mean and median are to the left. See that? Left of the mode. Okay, so let's do this with colors. So here's the mode. Doesn't really change much. Shaq came into the room. The median's kind of staying right there. But in comes someone who is gifted height-wise, but not so tall. What does that do? The measure of center that is most influenced by this outlier here is the mean. It can be pulled. The numbers get pulled. Okay. Another way of explaining it is the median is resistant. It's not going to get pulled so much by an outlier, someone who's super tall or super short. Okay. So that kind of shows it visually. I'm just going to do a chart on the next page. So let's go ahead and do that chart. All right, so page 2, big idea is choosing the measure of center. Okay, and the question you're going to ask is it symmetrical? Is it symmetrical? Does it look like this right there? Okay. Let's try to color code this. Like, I always think of lights, like green light, yellow light. So if it is symmetrical, make a chart here. And this is called the measure of center that we would use. And over here is the spread. We actually talked about that before. Remember the jam? Okay. All right. So the measure of center you would use, if it is symmetrical, you will use the mean. And another word for the mean is kind of like back in your early days, they call that the average. The formula for that is x bar. The summation of all your numbers. So symbols are important. Summation, that's what that backwards E stands for. You just means add them all the numbers up, and then you basically divide it by n, which is the number of items in your list. Okay, this one's going to be new to us, but we're going to learn it later. So the best spread is the mean absolute deviation. Mr. Ring, you got to be mad. Alright. Okay, what would happen though if no, it is not symmetrical? Then, okay, so if it's not symmetrical, I want you to think about this. In these 3 pictures, if it's not symmetrical, then you're crossing it off, then basically it's what? It means it's skewed. It's skewed. So I'm going to write that out here, skewed. Okay, what is our measure of center? You will use the median. And then something we're going to learn later on is called the interquartile range. And that is abbreviated by IQR. And basically, this comes from something, a future lesson, but I just want to write it here so you kind of 5 number summary. Okay? So you'll look at, just ask the question, is it symmetrical? If it is symmetrical, then you do the green light. If it's not, no way, it's skewed. No, it's not symmetrical, then you do what's in pink. Okay?
Alright, I wanted to add to this. The mean absolute deviation is also good when you have some, sometimes when you have some outliers, even within this. But the best one to use in the spread is the standard deviation. So when you are symmetrical, the best measure of spread
is use the standard deviation. And let's talk about standard deviation. So you have this big bad formula. Okay, let's try to color code this. Standard deviation is S. So S means standard deviation. And it is important for these abbreviations because we can actually see these on the calculator. Okay, let's look at some other things. Here in green, that symbol is called sigma. It's a Greek letter of the alphabet. And basically what it means summation. What math word do you see in there? Sum. You just need to add up the numbers. Okay? All right, let's keep going here. XI is the individual data points. So XI is the individual data point. Let's change colors here. That's called X bar. Do you guys know what that is? This is called the mean, or a simple word is average. But again, I rather use the word mean because it's more accurate. Okay. What other colors we got? Okay, and then the last one is N. N here just means the sample size. How many numbers do you have in that list? How many people are you talking about when you say Pokemon cards? There's 10 kids there, okay? Okay, let's look at this formula over here. Looks intimidating, but it's not. Okay, so variance is another variability, but all you need to do for variance is just find S in standard deviation and then square it. That's it. So those are your formulas. Okay, standard deviation is big and bad. We're actually going to use that. Variance, you're not really going to use that one. You are, but all you have to do is just take that value and then your answer and square it. Okay. All right. So let's do an example. Use the following ages of my kids: 1, 3, 5, and 7. Okay, it's just meant to be a super easy example. Okay, let's go through these steps. Find the mean of the distribution. So the mean is the summation of all of our numbers and then divide it by n. So what does that mean? You just take all your numbers and then divide it by, well, you have 4 numbers, right? Because you have 4 kids here. I actually have 5. So if I add all those together, 10, 16 divided by 4, that means I get a X bar of 4. Okay? All right, what do we do next? Calculate the deviation. So let's make a chart here. Let's make this really big chart here. Okay. Here is the numbers. Xi basically means I is a number. So for example, this would be x1, x2, x3, x4. It's just a number in the list. Does that make sense? So that would be, let's use orange because it started 1, 3, 5, and 7. Okay, what do you do next? So we did this one. Calculate the deviation. What's the deviation? It's the value minus the mean. So it's going to be xi minus the mean. So we already have these numbers, 1, 3, 5, and 7, and we're going to subtract that from the mean, which is here in I highlighted in green, so I'm just going to write down that number down that list. It's 4. Oops, that's a highlighter. So that number is going to be 4. Okay, so if you actually compute these values, 1 minus 4 is negative 3. Use your calculator, guys. No excuse for positive and negatives. 1, and then 7 minus 4 is 3. Okay? So we just did that one. Okay. Square each of the values now. Okay, so I'm going to write out the formula, and you're basically just taking these values, we just subtracted them, and now we're going to square them. Okay, so let's square them. So I have negative 3 squared, which is positive 9, negative 1 squared, which is 1, 1 squared, 1 times 1 is 1, and 3 squared is 9. Okay? Now it says add up, let's use a highlighter here. Add up all the deviation. So right there, we're adding those all up. Okay? So that number is going to be 20. Whoops. 20. And then it says divide that number by n minus 1. Okay? So I'm just using the formula right here. And our n value is 4. So let's write out the formula, see what we've done so far. Okay? You've taken the values in the list, and we found the mean, and you subtract it by the mean. And then we took all those values and we squared them, and then you divided it by n minus 1, so that should have been a 3, because it's 4. 4 minus 1 is 3. Let's erase that. And then you added up all of those values, right? That was a 20. And then the last thing we need to do is just take the square root of that number. Okay, so let's go ahead and do 20 divided by 3, and we'll take the square root. So, calculator, where are you? Calculator, there you are. And I'm going to clear that. So 20 divided by 3 gives me 6 2/3. Okay, I want a decimal. Okay, so there's my decimal, 6.667. Okay, now we need to take the square root of that number. So square root is next above top left of the 7. It's in blue, so second square root. You don't have to do exact. Okay, so I'm going to round to the nearest hundredth or thousandth, so that would be 2.582 would be the thousands. Thousands is 3 decimal places. $2.58.2. 258.2. 258.2. 2. 258.2. So we had to take the square root of 6.6667, and that gave me a standard deviation of 2.582. Okay, so that answers the question of the standard deviation. So that was only 4 numbers, guys. It gets bigger and better. Okay, so what did we do again? Write down the numbers in the list right here, and then we're going to take those numbers and subtract it from the average, which was the green over here. And then you get an answer, and then you take all those values and you're going to square them. So that's what we did in this column. And then I took in the highlighted there, I added up all the squareds and got here in circled in blue. and then we divided that number by n minus 1. So n was 4, so 4 minus 1 is 3. So 20 divided by 3 is 6.667, and then I took the square root of that number, and that gives me the standard deviation. So it is that much work. But go step by step. And let's go ahead and try another one. All right, let's go ahead and try this problem. They call this the grocery bills, buying food. And it says, has all this data. Calculator here. And I'm going to go to Stat and Edit. Now, again, if you want to do what I'm doing here, yes, you can use your iPad, but once we go back to school, it has to be a calculator, so I recommend doing that. I'm doing this more for presentation format. So I'm going to go up to where it says L1, and I'm going to press Clear. You can also get a graphing calculator, like a TI. That's one I know how to use best. So I'm going to insert all of these numbers. 1053, 1367, and 1501, 1830, 2089, 2707. Okay, so if you make a mistake like I just did, you can just put the decimal 07, enter, 3282, 3757, 37.57, 5236. Okay, so those are my 9 numbers there. So now I have them in L1, so I'm going to press Stat. I'm going to move over to Calculate and 1var stats. And I need a list here. To get this list, it's in next to the left arrow, so I'm going to press Second Stat and click L1. Okay. Ta-da! My average is $25. You see an X bar on top left there. 25.36. 25. Oh, look at that! It calculated the numbers, and then on the far right there, it actually has the. Can I zoom in? No, I can't. It has here the 5-number summary that we just found in the previous problem. But I wanted the average, 25.36. So let's go ahead and put that into our notes. 25. X bar is 25.36. Okay, so let's put in all our numbers here. I have, we're going to take all of our numbers. You can write them down if you want. There is 9 numbers in the list. And those numbers are 1053. 1367, 1501. You guys got to do it step by step. Do it with me. That's why I'm recording these videos. It's just like we're in class. 2089, 27.07, 3282, 3757, and 5236. Okay, what do we do now? We're going to take our numbers and we're going to subtract it from the mean. So I'm going to have to take $10.53 and subtract it by the average that we just found, which is 25.36. Okay, so we got subtracting all that by 25.36. And then we're going to get some answers, right? So let's get those answers. All right, so if you subtract $10.53 minus 25.36, you'll realize your positive number is smaller than a negative number, so I'm going to get a negative number. So negative 14.83. This one's going to be negative 11.69. So use your calculator, just subtracting here. Negative 10.35.
negative 7.058, negative 4.468, 1.7122, $7.4622. If I subtract those two numbers, I will get 12.212, and then I got 27,002. Okay, so let's review what we've done so far. We've taken our numbers, I've subtracted from the mean. Now I'm going to take these numbers in blue and we're going to square them. All right, so if I square these numbers, take negative 14.83 and square it, you're going to get some bigger numbers. 219.86, 136.6, square that, you're going to get 107.08. Square this one, you will get 49.812. Negative 4 point, that gives me 19.961. Square this number, 2.9317. And remember, if you're squaring any number positive times a positive or negative times negative, it'll always be a positive. So all these numbers here I'm writing in yellow should be positive. 55.685. Square that number, you will get 149.14, and square this number and you get 729.12. Okay, in yellow there. If you take all these numbers now, the formula is the summation of all of these values now squared. So if you add up all of these numbers here in orange, you will get 1,470.191,756. Okay, almost there. So the standard deviation, the formula is S equals the summation of all of those numbers you just did squared divided by n minus 1. So if I take all those numbers, now I get 191,756, and then our n value was, there were 9 numbers, so 9 minus 1. If you do that, if you divide first, you'll get 183.774. And if you take the square root of that number, the standard deviation is going to be 13.556. This is the standard deviation. What does that mean? That means if you have a bunch of grocery numbers, right? Maybe you do the grocery shopping at your house. I used to do that. And the question is, how much is that spread? Well, the spread is going $13 in some ways in both directions. Okay, it can vary. Okay, variance. How do you get the variance? Well, remember, this is so fast. Hey. Variance is just s squared. So if s is equal to this number, if you just square it, you'll get s squared, which is variance. And that number would be, if you think about it, it's already above 183.774. You see that number right there? So that's how you found standard deviation and variance. Okay, so you will have to calculate this by hand. Okay, I can tell you take a picture of your work, turn it in quiz or test. You got to show it to me. But let's see. Look at that number. Do you see it? SX on my screen. That means your calculator can figure out standard deviation by hand. Oh my goodness. 1356. 1356. Yes, that means it can go a lot faster. Okay. Let's see. Let's go to stat. Edit your list. You have the numbers in that list. Okay. Let's try something. L2. I just want you to let's see. So I'm going to put all this into the calculator, and it actually can calculate a lot of these values for me. So edit, list, go down, and no, I want that to be L1, second, stat, L1, enter. No, it's kind of hard to do here. I won't do it because I can't. So a graphing calculator can kind of make the table, but you can just spit it out. And you can actually also figure out the standard deviation with your regular scientific calculator. You just have to figure out how to put it into the list. So I want you guys to go to the next problem, college history here, and I want you to do it. And then I'm just going to work it out. And so in about, when you press pause it and you press play, you'll see the whole answer there. So go ahead and try this last problem here for some practice. All right, so college history, 12 numbers. I took all my numbers, put them from least to greatest on that far left column here. And then I found the average, which is 86.5, subtracted all those values. I got an orange. Then I take the orange values and square them to get the green numbers. Add up all the green values, get 481. And then take 41 divided by n minus 1. I get 43.727. Take the square root of that, and it gives me a standard deviation of 6.613. And if you just take that number and you square it, you'll get the variance.
All right, let's go over 8.32, calculating statistics now using technology, or kind of what I showed you in the last problem, but I'll go a little bit slower this time, and let's go over all the calculator commands. All right, so now that you've appreciated that we did it by hand with that chart, the first thing is on your graphing calculator, enter the data by pressing the button Stat. Then you're going to select Edit, and enter all your data into a list. Now you can choose list 1, list 2, list 3, whatever you want. And then you're going to press Stat again, Calc on the menu, and then select 1 bar stats. And then you're going to press Enter. Okay? Those are the step-by-steps, and then we're going to get this calculator screen, and when we get a calculator screen, I kind of want to tell you what each of these mean. This first one over here, this one is going to be the mean or average. This one in orange is going to be the sum of the values in your list. Sum, or adding them all up. Sum of the values. This is sum of the squares. Sum of the squares. Okay, this one is the sample, standard deviation, okay, for the problems that we're doing, we're looking actually for this one. So I start it, and this one is our Well, I guess we're trying to find 2. We're trying to find the mean, oops, the blue one, and the this is called the population standard deviation. And the only difference on the formula that we're using on the previous problem when you guys were doing it by hand is that the formula was divided by n minus 1. This one you're just dividing by n. That's how you would do those problems in the previous one. And then over here, we might learn it later. I'll just tell you these are the, not for our lesson, but these are called a 5-number summary. And that helps you create a box plot. Okay? All right, so let's do this example number 2 here. All right, the first thing I'm going to do is I'm going to go to my calculator, Graph and Calc 83. I'm using the iPad, and I'm going to press Clear on the far right there, and then I'm going to press Stat, which is next to the left arrow key. Then it tells us to press Edit, or you can press number 1. And then it says enter all your data into your list. Now you'll see the cursors on that 2.2, and I have a bunch of stuff in there. So what I'm going to do is I'm just going to clear everything out. So you go and highlight the L1 and press clear. Again, let's press enter. Go on to top of list 1, press clear, then enter. Okay. And you're just going to put in the numbers. 26, enter. 12, enter. 15, 20, 17, 19. And the nice thing is you look at there, it says list 1, 7th. That means it's the 7th number. And this will kind of help you double check just in case you make a mistake inputting your numbers. Okay, now that I have all of my data, I'm going to press Stat, which is next to the left arrow key. I'm going to press Calc now. Do you see how it's highlighted on Edit? But I'm going to press Calc. And then I'm going to click 1var Stats. Now it's going to give me a calculator command here on the home screen. And the default is L1. The default is L1. And if you just press Enter, it'll actually give you your answers. You don't have to designate the list that you put it into. Now this is what we were talking about. Okay, the first number, x bar, is the mean or average. That is what we wanted. And the population standard deviation is the one we wanted. It kind of looks like ox, but it's a Greek symbol there, so that would be 3.7. All right. So we did that, and our x bar doesn't tell us where to round, but I'll round to the nearest tenth. This is my mean. And then we said that the population standard deviation was 3.7. Population standard deviation. Okay, so you just have a bunch of practice with your calculator problems. It's kind of hard to see. That's question number 3, 4, 5, and 6. Let's go ahead and do those. Let's go to my calculator. Cleared it, Stat, Edit. Okay, go back to the top of your list. Clear, Enter. So for question number 3 would be 20, enter, 23, enter, 24, 23, 22, 25, 21, 23, 24, 22, 21, 23, and 24. Now for the last one, don't forget to press enter. And then we're going to press stat calc, which is in the middle, 1 bar stats, and you can just press enter here. There we have our X bar to be 22.6. We should round up 1 because it's to the nearest tenth, it tells us. And then the population deviation would be 1.4. So 22.7 and 1.4. And a good idea, I just want to show you guys this trick. Remember, it says definitely skip 1, but if you count the number in our list, I'm just going to write the numbers above it, show you how. It's very tricky where a lot of students will actually miss that. So n is equal to 14. There's 14 numbers in our list, and if you go back to the graphing calc, you'll notice that I have 13 there. Okay, what does that mean? That means I missed a number, and that's why my numbers are off. So if I look at my numbers, stat, edit, let's go. Did you catch the number I missed? 20, 23, 24, 23, 22, 25, 21, 23, 24, 22, 21, 23, 22. I missed a 22. Okay, so this is what you can do. Order does not matter. Order does not matter. Stat, calc, 1 bar stats. And there you can see now I have n equals 14, and I should have 22.6 and 1.3. Let's change that. .6 and 1.3. So a good way of double checking your numbers. Let's do that on the next one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers. So let's go ahead and go to my calculator. This is the home screen. You just turn it on, press clear. You're going to press stat next to the left arrow button, edit. Go to the very top of your list, clear, enter, and let's try not to miss a number. 150, 153, 125, 136, 143. See, I messed up. Look at that. Come on. 150. 153, 125, 136, 143, 150, 166, 148, 150. That was supposed to be 150. Hello. 173. 150, 153, 143, 142, and 153. Okay, now after you press enter, even though we have 15 numbers on the list, it's asking for the 16th number, which we don't need. Press on the left arrow key, stat, calc, which is in the top there. 1 bar stats, press enter, and there we have 149 is our average and 10.9. So average is 149 and population standard deviation is 10.9. Let's go ahead and try number 5. I'm going to number them just in case. This helps me make sure I don't miss a number. As you saw, it is very easy to miss a number. Okay, clear, stat, edit. Go on top of the list, highlight, press clear. And list number 1, 9. So you don't need to put the decimal for 9.0. 6.2, 7.1, 5.3, 6.2, 7.1, 8.2, 7.1, 4.5, 9.9, and 8.2. Let's go stat, calc, 1-bar stats. And then our answer there would, X bar would be round up, 6.9 and 1.7. So let's get a different color. It's hard to see. X bar is 6.9 and the population, which means we have all the numbers in the list, 10.7. And let's do our last one here. Twelve numbers. Clear, stat, edit. Go on top of the list. Clear. Let's put in these numbers here. 3,000, 350, 2,800, 45, 25, 2,150, 2,800, 2,150, 3,350. And if you're using your regular calculator, I would highly recommend like punching in numbers really hard. It's a common mistake is you miss a number, so just like firmly press it. 3975, 580, and 2800. Okay, stat, calc, 1-bar stats. And we have 2960.8 and population 1205.1. Let's go ahead and write that. $2960.8 and whoops, population standard deviation is 1205.1. Okay. If you get kind of, it's just calculator commands. If you are running out of space, I would recommend just box your answers so you can kind of see those very clearly. But we don't have a lot of math work there. Okay, let's go on now to 8.33, describing graphs. And the 4 ways you describe graphs or data are using the acronym. Don't forget to use your SOCS. And it's spelled differently because you're just going to use that, okay?
So this is the S in SOCS. So the first one is called shape. And the first one is called symmetric. What is symmetric? Same on both sides of the distribution. Remember, another name for distribution is also called a graph. There's a phrase we have. We say approximately normal. Alright, so let's give you our symmetric shapes. There are 3 of them. Start with the first one in the box on the left there. If you have this one, and you have a couple of graphs, this one they call bell-shaped. Bell-shaped. Why do they call it bell shapes? Because you're going to do this and paint another color. It might be helpful you see this. That pink there, they call it, looks like a bell. And then they also call this one unimodal. And unimodal, una means one. There's only kind of like one graph here. It's all lumped together. It'll make sense when I do the next one. All right, let's go to the next one. So let's say you have a graph. Sorry, screening the tip of my pen. Way better. And say it looks just like the other side. So this one, they would say there's kind of like 2 chunks. There's 1 and there's 2. Do you see the gap in between? So 2, they would say, is bimodal. There's 2 kind of big chunks there of data. And then you can just call the other one if you saw something. Well, count how many chunks there are. There are 3 chunks, right? 1, 2, 3. They wouldn't call that trimodal. They'll probably say they call this multimodal. All right. What is skew? What does skew mean? Skew means the tail. Let's make sure of the distribution determines the direction of the skew. Direction of the skew. I'll give you guys the 3 examples here. So this one we would say if a graph looks something like this and the tail is equal on both sides. So we would call this one no skew. If I draw another graph And we say all the data there is if I draw this little pink one, this might help. Oh, sorry. Bad one, bad one. Let's try that one again. This is my graph. And then so the tail is going over here to this side. What side is that? That is the left side. So we would call this one skew left. Skew left. The tail is going, which direction is it going towards? That's towards the left. And then if you did something like this. So over your bar graph or your histogram more accurately, then you're going to draw this, the bump, like a smooth curve over it. This kind of gives you the direction, so watch. And you're kind of like not touching any of those. And then the tail kind of goes off there. So it's going towards the right. So we call skew right. So another way you can think about it is instead of skiing, which way should Mr. Ring go? Skewing. And the data, and this is actually an example below of the dot plot. It says go towards the long tail. So this would be skewed left. All right, that completes page 1. Go down to page 2. All right, so now we're on page 2, and what does a shape look like with its different types of forms? And one we didn't talk about is if all the data is exactly the same, we would say that this one is uniform. Like if all the students, you guys wouldn't like it, but if we all wore uniforms at school, you all look the same. If you all look the same, then we say that your looks are like constant. The frequency is constant, like the number of I don't know how many hours you slept, and all of you guys came in and you guys all said 8. Okay, so that's what your graph would look like. All right, let's go down to now the O. The O in socks. What does O stand for? You might have actually heard it in another class. That's called the outliers. And what are outliers? They're AKA, also known as unusual values. Unusual values. So outliers are values unlike the rest. They're just different. Clusters are like isolated groups of data. Those are back to the modals, so I'm going to write that. Look above. Like the bimodals, unimodal. And then anything else is you're going to look for some gaps. Look for gaps. What are gaps? They are large spaces between values. All right, let's move on now to the C in SOX that is called the center. The center. What is the center? A typical value off in the middle, value that would best describe the center. Sorry, describe the distribution. Remember, distribution is just your picture of your data. So there are 3 ways of measuring the center. The first one is called the mean or average. And a way of finding it is taking the sum. And the sum, you're going to have these symbols. It's a backwards E, that's called a sigma, divided by the number of fancy word add-ins. Explain in a second. Here's my example. I'm going to have 3 numbers. How many Snicker bars did you have in the past 3 days? Maybe you had 1, and then you're really hungry, you ate 7 of those the other day, and 7. Okay, so the sum would just be adding those up together. And then the add-ins is just how many numbers do you have? 1, 2, 3 numbers. And this would give you something called the average. I'll show you a future symbol as well. X bar. So that would be 1415 divided by 3. So our average or mean would be 5 is our answer. Let's practice boxing our answer. All right. The measures of center all start with an M. So here's the second one. And this is the median. And I'm going to highlight started. This is the best one. Or the middle. Another way of thinking about this is, you know how at school, you guys are at the horseshoe in front of school, and then you want to get to the french fry place at the golf course, and then you got to cross the street. And then there's this thing called the median. It's in the middle of the road. So hopefully that helps you remember. So how do you find the median? Well, it's just the middle. So let's do another example. What are my numbers? Let's say you have a couple of numbers. 1, 7, 7, 9, and 22. I also want to emphasize, did you notice that they're in order from least to greatest? They call that, the numbers are ascending, because the numbers are getting up bigger. Okay, so I'm going to number these. So let's just say you have 1, 2, 3, 4, 5 numbers, okay? And you want to find the middle, right? The middle. So I have, this is how I do it. There are 2 to the left and 2 to the right. That means 7 is in the middle. 7 is the median. Okay, let's do another simple example. So let's just say I have the numbers 1, 5, 7, and 22. So what's the difference? The previous problem I had 5 of those. 5, right? 1, 2, 3, 4, 5. That was odd number of data. Okay, and this one has what? 4 of them. 4 is an even. Okay, pay attention now. I should have did it in a different color. Evens, well, you think about it. If I want 2 to the left, 2 to the right, then it's actually right down the middle. And what do you have to do here is you need to find the average of those two numbers. So 5 plus 7 divided by 2, what we just did in the previous problem. So 12 divided by 2 is 6. 6 is my median. Now you might say there is no 6 in the list of numbers, and it's correct. But to find it on an even set of data, you're going to have to find the average between those two numbers. Okay, so again, the first example was there were odd because there's 5 numbers. But in the second example, I had 4 numbers, and you have to find the average of those two because there is no middle number there. Mean, median, and last one is mode. So our third M is mode. And a phrase that helps you is most. What number comes up the most? Here's our example. I have 1, 7, 7, 9, and 22. And it doesn't matter, but a good strategy, again, let me highlight that, is you want to put your numbers in order. That way you can kind of see the numbers put together. Okay, so let's make it a little bit more complicated. Let's just say I gave you this set of numbers. Okay, this is how I would do the problem. Okay, so let's say I give you the white. Let's erase the orange. Okay, that was, and what I'm going to do is I'm actually going to just put these numbers in order. As I do them, I'm going to put a little check mark. Soup for helpful. Whoa, that was on erase. Soup for helpful hint. 1. Write it, smallest to greatest. Okay, 7. Put a check mark because these numbers are going to get like 20 numbers long, 50 numbers long, and you're going to lose track of all the numbers. That is actually one common way of missing the problem. You forgot one set of numbers in your data. Okay, so you just put them in from least to greatest, and then you're just going to pick which one happens the most or most often, and that is a 7. So the mode in this problem is 7. That's what we would say is our answer. Okay? All right, let's get to the last letter of SOX. We have S, stands for shape, O for outliers, C for center, and then S stands for spread. What happened? There we go, spread. If you guys are realizing we're going to be doing this every day, like, you know, it's a lot of information, and you might want to just, you can do what I'm doing. I'm using my iPad and not an Apple Pencil because that's pretty expensive, so I just got like a cheaper pencil. You can contact me and I'll let you know which one I got. Okay, so what is this? Determined by amount of data that varies from the center. Consider how close the data values are to the center. And if the data sets are close to the center, then there's little spread. And if the data points are far to the center, then there is more spread. A formula you might need is the range is equal to the maximum. So a way of figuring out the spread is using the formula for the range minus the minimum. And then here is my example. Here is my 2 pieces of toast, and we said if the data points are close together, pretend you have toaster bagel. Let's just say this is your jam. And the jam, just when you plopped it onto your bread, it was just really close together. That means there's little spread, right? You're kind of thinking like, well, I got to get my jam all the way to the edges there. But when you plopped it on there, it didn't really do much. Now, if your spread, when you plop it on, whoops, that should have been blue. If it is far, right, way out here, then you have lots of spread. It's spreaded out all over the place. Okay, so that's how we would describe those.
All right, example 3 here. Examine the scores for 2 Algebra 2 classes are shown. Use the mean and standard deviation to compare and describe the distributions. Go ahead and put those into your calculators, and you should be able to get a mean and a population standard deviation for both Mr. Ng's Algebra 2 class and Mrs. Ng's. And then go ahead and write those down, and then we're going to compare them using our socks. Okay? Alright, so I went ahead and put in the numbers into my 2 lists, and then stat, calc. This would just give me the statistics for Mr. Ng's class, right? And if you want to do the same thing for Mrs. Ng's, calc one var sets. Okay, before you press enter here though, this is where you want to designate list 2. So I'm going to press vars, which is down by the down key. And no, not one of those. Try second vars. That was it. Second vars. Nope. Oh, I see it. Second stat. Next to the left key there. And then you're going to just designate it list 2. And then this numbers here are the mean and population deviation for Mrs. Ng's math class. Let's go ahead and write that in there. So that would be a x bar of 93.2 and a population standard deviation of 2.3. And Mrs. Ng's class had an average of 79.9 and a standard deviation, 79.9 and population deviation of 7.2. Okay, so we talked about socks here, and all right, for Mr. Ng's class, we can say that the shape is going to be Mr. Ng's, so this is shape. Mr. Ng's class is more symmetrical. And how do I know that? Is because the standard deviation here is a low number. And because this is a low number, that means most of the data is in the middle and it's not spread out. So it's kind of squished in there. The jam is not spread out. The variability is low. Now, Mrs. Ng's class, this one is, in the middle is 79.9, and because you have a bigger standard deviation here, that means the jam is more spread out. The variability is more spread out. So, right, Mr. Ng's class is more symmetrical, while Mrs. Ng's has more variability. So we don't have a shape because you can just make a dot plot yourself, but I don't want to take the time to do that. Okay, how about any outliers? Any numbers that are just like that just seem like really way off? Outliers. You're right. Doesn't appear to be any. Doesn't appear to be any. I'd be looking for like someone who scored like a 20 or a 30 or a 10, or in Mrs. Ng's class, if there were no 90s, right? I see that in 92. If those were gone and everyone else was scoring in the 70s, 80s, and someone had a 100, that might be a possible one. Okay, and our C here, we want to see which one would be a measure of center. In this case, we could just talk about their means. So their mean, who has a higher mean? Mr. Ng's mean score, not a nice score, a mean score. Mr. Ng's mean score is what? Higher. So we're comparing or describing here than Mrs. Ng's. Does that make sense? I'm just looking at 93 to 79. Okay? And last one. What is our spread? And our spread is our standard deviation here. Who has a higher one? Mrs. Ng's. Class has a higher, or you call greater. So these are my words that are, comparing. It's about the same. You can say less. It's greater. Greater spread, which is our standard deviation, then, whoops, don't need a period there, Mr. Ng's. Okay, so that is our example number 3. Let's go ahead and move on to the track here. I'm going to pause the video and get an average and a population for both of these, and then go ahead and press pause and get those numbers, and then come back, and then we can write that SOX together. Okay, for the track, I have 9.2 and 1.0. And then after the season, I have a 7.0 and a 0.9. So let's go ahead and do our SOX. So what is our shape? Again, this one's a little bit hard, but this one has a lower, they both have lower standard deviation, so we're going to say we both seem to be symmetrical or unimodal. The data is not all crazy everywhere, that's the point. Do they appear to be any outliers? Someone way out there. So remember, in stats, we're trying to use words that are not so like absolute. Doesn't appear to be any outliers. How about what's our C? Our C is our center. Now we can compare it. Mile time before the season is greater than after season. Okay, you have to think about this in context because those 20 track members, it makes sense, right? As you get in shape, you cross country, you've just been hanging out on the couch all summer long, and then you start training, and you train for every day. Then at the end of the season, you're like in tip-top shape, and so of course your scores are actually going to be lower. So we expect before season, you're kind of slow, and then you just work at it, you work hard, and you got faster times. Okay, what is our spread? Both, they're kind of the same. So we could say both mile time before and after season are the same. Do you see how I'm saying that they're pretty much the same? Right? It's not like you're drinking energy drinks. It's not like you had foot pains. You're kind of just consistent in the team's times. Okay? All right. Go ahead for question number 8. Press pause. Get the mean and population standard deviation for both the geometry classes, and then go ahead and write out your SOCs, and then we'll do it together. All right. That's a mean. X bar. Try it again. 86.5. This one is 11.0. This side 77.5, and a standard deviation of 13.7. Let's do our SOCs. Okay, this one we don't have for our shape. You can get a dot plot. I haven't taught you that yet, but for now, we would just do a dot plot by hand. So you can try it. Need to graph the distribution. Any possible outliers? Yeah, I think for the geometry class 1, class number 1 has a 58 score, and I see this 40 because the 98s are close to that 100, but I have that 40 is pretty low. So class number 2 has a 40 score. These are possible outliers. I'll give you a formula about that in a future lesson. Okay, what measure of center do we have? Well, the only one we have is the mean. So we can say that class number 1 has what? Comparing these numbers here. Has a higher mean score, and you compare it to who? Then class number 2. Okay, these are kind of like just text-dependent questions, as you would say in your science, history, English class, right? The text is our numbers, and what I'm trying to just say is comparing them. Okay, last one. What is our spread? And that, in case, is our standard deviation. So, what do we notice? Okay, so class 2 has a class number 2 has a higher, greater, English teacher's going to be laughing at me, Class number 2 has a higher standard deviation. We could say population to be more specific. Population standard deviation than class 1. Right? Those are facts. Okay, so down here, these are optional. That means you don't have to do them. And so just to review, we're using statistics, and we're describing these distributions by using standard deviation. We'll see you guys later. Bye.
I love math, the way the path goes on the graph, power functions. Cause great discussion in the math class. Shall put no textbook before the math class. Functions real radical and very graphical. That's the way it goes in the math class. Some of the real bros.